Section 3.3, intersection and union of two sets. So we have Jackie. She's a zookeeper, and she's responsible for feeding baby animals that cannot be fed by its mother. She needs to feed a baby raccoon every 2 hours and a baby lemur every 3 hours. She uses the 24-hour clock to plan their feeding time. She starts to feed the raccoon at 2 and the lemur at 3. So there's a little bit of a note here about the 24-hour clock. So we go 0, 2, 3, 4, 5, all the way up to 12. Then 1 in the afternoon is 13 o'clock, 2 in the afternoon is 14 o'clock, whatever. Okay, so that's just, they chose to use the 24-hour clock because it's going to be easy. So let set T represent all the hourly times. Let set R represent every 2 hours up to 24 hours, and let set L every 3 hours for up to 24 hours. Describe the universal set and the subsets in set notation. Okay. So T is the universal set. So T would be all of these. What that looks like in set notation, will be right here. So in set notation, it's going to be all hourly times from 1 to 12. R is multiples of 2. L is multiples of 3. So this is one way. We also could have written this like this. We could have written it. So set notation, we have squirrely brackets. We could have wrote 1 o'clock. We could have wrote 2 o'clock. We could have just kept writing all the way up to 23 o'clock and 24 o'clock. Okay, R would have been all the multiples of 2. So R would have included, all the multiples of 2. So we would have 2 o'clock, we would have 4 o'clock, 6, 8, 10, 12, 14, 16, and so on. And 24. Okay, and then the multiples of 3, so we'd have 3, 6, 9, 12, okay, so this is what those subsets would look up. Sorry, my squirrely brackets aren't for that. Okay, so list the elements, we've done that. Represent the sets using the Venn diagram. Place the feeding times in the correct region. Explain why you place them. So the raccoon is, remember, 2, 4, 6, 8, but 6 is in both. So we're going to put 6 here. What else is in both? 12. We're going to put 12 there. Looks like our next one is going to be 18 is in both. And then finally 24. So now we're only going to fill the missing elements in. So this would be 2, 4, 8, 10, 16, 20, and 22. And left here we have 3, 9, 15, 18, 21. Okay, and so the times when we're not feeding anyone is 1 o'clock, not feeding anyone at 5 o'clock, 7 o'clock, 11 o'clock, 13 o'clock. Seems funny to say those things, doesn't it? 17 o'clock, 19 o'clock, and 23 o'clock. Those are the ones that are not included. So every element is listed, but we show where those things are. Represent using the Venn place. Yep. So that looks good. I think I have it on the next page typed out really nice. That looks much better. Okay. List the elements in the intersection of R and L. And intersection is this symbol right here, an upside down U. It's common in 2 or more sets. So R intersect L, all the things that are intersected are 6, 12, 18, and 24. Okay, list the elements in the set R, not L. So these are all the things that are in R, but not L. So that's all of these things in blue, but not in purple. So that's 2, 4, 8. Okay, so I've continued listing all the ones that are in R, but not L. All the ones that are in L, but not R, that's what this notation is all of these ones that are just in red. So that's 3, 9, 15, 21. Okay, so the set of times that belongs to either a feeding schedule of 2 or of R forms the union. So union is everything in together. List all the elements. So union, we take everything in blue, everything in red, and everything in between. But we only write things once. So I'm going to show you what that looks like in a nicer way. So this is, look, we did 2, 3, 4, all the things that are 2, 3, 4. We're going to include 6, everything that's in all 3 of those regions. Okay. Next it says list the elements of the complement. So complement says everything that's not in R union L, and that would be all of these guys here. Okay, and that's what they've done in this question, is they have written the complement. Okay, so just remember what complement, union, and intersection are. So union means in both. Union means in both, including the intersection. Intersection is only the middle part. Okay, sorry. Here's just a little communication. A union B reads as intersection A of A and B. It denotes the elements that are common to A and B. The intersection is where the two sets overlap. So we're only talking about this middle part. A union B is read as the union of A and B. It denotes all the elements that belong to at least one of A or B. The union is the red section, so all of it. So A union B is generally bigger than A intersect B. Okay. A slash B is read as A minus B. It denotes the set of elements that are in A but not in B. So A intersect B when B is included in A. We're talking about just all the red things. A but not B when they're disjoint, when there's nothing in common. I'm only talking about this red. And here, when they intersect, I'm only talking about the red, not the white. Things that are in A, not B. A minus B. Okay? Last thing I want to go over is at the very end of the chapter, you have a very good, another key idea is what union and intersection means. But this is pretty important down here. Okay. If two sets contain common elements, the number of elements in A or B is written like this. The number in A union B is the number of A plus the number of B minus everything in the intersection. This is called the principle of inclusion or exclusion. To calculate the number in A union B, subtract the elements in the intersection so they are not counted twice. So in other words, if I have a Venn diagram like this and I want to know what's in all of that, I say, well, how many are in here? How many are here? Add those together, but subtract this because you've counted it twice. If two seats are disjoint, if there's nothing in common, then the number of A intersect B, there's nothing in common. So in order to get A union B, the number of elements, just add A and B. Add how many are in A and how many are in B. Elements that are in set A but not in set B are expressed as A not B. The number of elements in A or B, number of A union B, can also be determined as follows. The number of A not B plus the number of B not in A plus the inclusion. So in this case, what we do is we say what's here plus what's here plus what's in common. So more than one way to get the correct answer.